doing our video on the 1,2,1,4 addition of an HBr2A diene.
This is a mechanism of 1,2 addition on a symmetric diene with HBr in cold conditions. First, this is going to take the hydrogen and the electrons are going onto the bromine. Because this is going to be Markovnikov, the carbocation is going to be on the 2 carbon. And the negative bromine then wants to attach onto this positive carbocation, forming the 1,2 product. However, there is 1,4 addition on a diene in hot conditions with HBr. The first step is the same, where the hydrogen is taken on by the double bond, creating this carbocation intermediate right here. And because of the heat, this double bond shifts into the center, creating a more substituted double bond. And the carbocation then goes here. This negative bromine wants to attack this positive carbocation, creating the 1,4 product.
The kinetic product, we always do the 1,2 addition. Say we have this diene. You always number from the more free carbon, and that would give us a carbocation over here, to which the bromine then attaches. Say we do the 1,4 addition over here, and this would be hot. It would give us a carbocation over here, which rearranges to with the cation over there, and the bromine attaches to it to form this. If we did, this is the 1,4 product. If we did the 1,2 addition, we would get the same as above, which would be this. As we can see, both of them are di-substituted, but due to the resonance of the benzene ring, this would be more stable. Hence, to reiterate, the kinetic product would always be the 1,2 addition, whereas the thermodynamic product would always be the more stable alkene formed.
So, for example, with this practice problem, if we add HBr under cold temperature, this is going to be a kinetic reaction, which means it's going to be a 1,2 addition. So the double bond is going to take the H from the HBr, the bond is going to go to the Br, and so it's going to form this intermediate with the Br, which attaches to the carbocation, which then becomes, and so this is a 1,2 addition, but it's also racemic because it forms the carbocation, and so the bromine can be attached from the top or the bottom. When HBr is added under hot temperatures, however, it starts off the same, with the double bond stripping the hydrogen off the hydrogen bromide, and a carbocation will form at carbon 2. But because of the hot temperature, the double bond on carbons 3 and 4 will actually shift to carbons 2 and 3. And so it'll look something like this. The bromine will attach onto carbon 4. And so the final product will look like this, which is also racemic because, again, with the carbocation, the bromine can be attached from the top or from the bottom.